In solving equations with variables on both sides, you have a couple goals. The first goal is to use inverse operations to get all the variables together on one side of the equation and all the constants together on the other side, and then, of course, solve. There can be many steps, but the same steps always apply. So it doesn't matter if it is a 2-step, 3-step, 4-step, 5-step, or 100-step equations, everyone's going to use the same steps. The first thing we're going to do is eliminate parentheses on either side of the equation by using the distributive property, just like we did in our last lesson. So I'm going to set this up first by drawing my fence down the middle. Of course, you don't have to do this, but if it helps you keep your thoughts organized and your work neat, then you can do that. All right, my parentheses here, first step, I'm going to distribute this +4 and watch that sign that precedes your number because it gets distributed as well to both the 1 and the +5x. So copy the rest of the problem, -8x, and then +4 times +1 is +4, and +4 times +5x is +20x, equals, copy the rest of the problem, -6x minus 14. Now I'm going to combine like terms on one side of the equation or the other. So if I look on the left, I see that I have a -8x and a +20x. So when I combine those, I get 12x. And then I'm going to write my +4 equals, and there's nothing to combine on this side. I have an x and a constant. So just copy those down. Now you're going to use inverse operations to move all the variables to one side of the equation. It does not matter which way you go. However, my tip is to look for the smallest coefficient. In this case, that's a -6. And I would move that one just because it's more likely that you'll have fewer negative signs, and I know you like fewer negative signs. So if I have -6x, I'm going to do +6x, adding 6x to both sides. All right, so that happens here as my -6x and my +6x cancel out. And then on the left, I have 12x plus 6x, which is 18x, plus 4 equals, those canceled out. That looks like an I. That's really awkward. Equals -14. All right, the next step is to use inverse operations to move all the constants to the other side of the equation. So at this point, you've decided your x's are going to be on the left. That means your constants are going to be on the right. So I have a +4. I need to do -4 on both sides. So +4 and -4 cancel out, and I'm left with 18x equals -14 and -4 is -18. This is working out nicely. 18 times x, so I need to divide by, that is a +18, not a -18, on both sides. And my 18 divided by 18 leaves me with 1x equals -1. Now we need to check our answer. So I'm going to go back, zoom out, and I'm going to plug in -1 anywhere there is an x, and then use order of operations to check. So -8 times, instead of x, I'm going to put -1, plus 4 times 1 plus 5 times -1, parentheses, equals -6 times -1 minus 14. So in order of operations, I'll do the parentheses first, and then inside the parentheses, I need to multiply before I add. So I'm just going to copy the rest of the problem. 5 times -1 is -5. -6 times -1 minus 14. Now I still have a set of parentheses. 1 minus 5 is -4. So I'm just going to copy the rest of the problem. And how many steps you do at once is kind of up to how comfortable you feel with the order of operations. Now I have a bunch of multiplication. I've got -8 times -1. I've got positive 4 times -4 and -6 times -1. -8 times -1 is 8. 4 times -4 is -16 equals -6 times -1 is 6 minus 14. So 8 minus 16 is -8, and 6 minus -14 is -8, and it checks out. So this reminder down here is quite important. Remember to use inverse operations when moving variables and constants across the equal sign. You cannot just rearrange the equation. When you have an expression and you are combining like terms, then you can rearrange. But an equation is just two expressions with an equal sign in the middle. So this expression over here I can rearrange and combine like terms, and this expression over here I can rearrange and combine like terms. But to cross that boundary line, you need to use inverse operations. On to the next page. There are some special cases when solving equations. Sometimes you'll get no solution. When you solve an equation with variables on both sides and eliminate the variables completely, leaving an untrue statement, the equation has no solutions. In this example, we see that we get -6 equals 10. That is not a true statement. That is false. Since it does not equal 10, there are no solutions to this equation. Infinite solutions happens when you solve an equation, eliminate variables completely, leaving a true statement. In this case, we have -6 equals -6. That is a true statement. And so there are infinite number of solutions. In other words, any number you put in for x would be true. Now, if you are looking at these, when you get to this step right here, 8x minus 6 equals 8x plus 10, you might recognize that that has to be a false statement, because if you have 8x and 8x being equal and you subtract 6 from one and add 10 to the other, that's not going to work. So you know at that point that this cannot be true. In this case, 8x minus 6 equals 8x minus 6, you might see, well, we have an identity here. They equal each other. Both sides are the same, therefore it's true. So x could be 1 or 2 or a million or -1,000,000, and both sides are still going to be equal. So the hardest part of this is just recognizing what type of special case it is once you see it. So if we do a couple practice, I think it will become apparent. All right, we have a multi-step equation here with parentheses. So first things first, I'm going to draw my fence down the middle, and I'm going to distribute my 4 times 3x is 12x, and 4 times 6 is 24. Copy the rest of the problem, equals -16 minus 8x. I want to get the variables on the same side of the equation. So here I have a 12x and here I have a -8x. Since -8x is less than 12, I'm going to do the inverse and add 8x to both sides. So now I have 12x plus 8x is 20x plus 24 equals -16, and then this -8x and positive 8x cancel out. So now I need to get rid of the constant, which is positive 24. So I need to subtract 24 on both sides, and I get 20x equals -40. Since it's 20 times x, I need to do the inverse, which is dividing by 20. And 20 divided by 20 is 1x equals -40 divided by 20, -2. Then I would go in and check my answer. Next problem, 16 minus 2x plus 6. Draw my fence. 38 minus 5x plus 8. I have no parentheses here, but I do see that I can combine like terms. So on the left, I have a -2x, That's the only variable term, but I have a positive 16 and a positive 6. So that's going to be negative 2x plus 22 equals, on this side, I have a negative 5x is the only variable term, but I have a 38 and a positive 8. So that's negative 5x plus 46. And now I've got variables on both sides, but I've combined all like terms. So I'm going to decide which variable I want to move. Since negative 5x is less than negative 2x, I'm going to add 5x to both sides. And notice when we do that, now we've gotten rid of our negative coefficients because negative 2x plus 5x is 3x plus 22 equals 46. Now I need to move my constant, which is positive 22. So I'm going to subtract 22 on both sides. I've got 3x, and then negative 22 and positive 22 cancel out. And 46 minus 22 is 24. Now I have 3 times x, so I'm going to divide by 3. And 3 divided by 3 leaves me with 1x equals 8. Next example. I see here I have parentheses, so after I draw my fence, I'm going to distribute that positive 2, watch your sign, to the negative 4x and the positive 20. So 5, and then 2 times negative 4x is negative 8x, and 2 times 20 is positive 40 equals 5 minus 3x. On the left, I have like terms that I can combine. I have a 5 and positive 40. That did not go well. There we go. So negative 8x and 5 and positive 40 is positive 45 equals 5 minus 3x. Now I'm going to move the variables to the same side. I have a negative 8x and a negative 3x. Negative 8x is less, so I'm going to do the inverse and add 8x to both sides. So on this side, my negative 8x and my positive 8x cancel out. I'm left with 45 equals 5, and then I have negative 3x plus 8x is positive 5x. Now I need to move my constants to one side, so subtract 5 on both sides, and 45 minus 5 is 40, running out of space here, wrote too big, equals 5x. Then I have 5 times x, so I'm going to divide by 5, divide by 5. 5 divided by 5 leaves me with 1x, and 40 divided by 5 is 8. So 8 equals x. Last example, I've got parentheses on both sides here. So let me draw my fence. Negative 10 times negative 2x is positive 20x. And negative 10 times positive 4 is negative 40. Equals, here I've got positive 2 times 4x is 8x. And 2 times negative 18 is negative 16. No like terms, so I just need to decide which one I'm going to move. 8x is the least coefficient, so subtract 8x on both sides. And 20x minus 8x is 12x. Copy the rest of the problem, minus 40. Positive 8x and negative 8x are going to cancel out and leave us with negative 16. Watch that sign and make sure you bring the sign down. Now I need to put my constants together, so I'm going to add 40 to both sides and bring down your 12x. Negative 40 and positive 40 cancel out, and negative 16 plus 40 is 24. I have 12 times x, so I'm going to divide by 12, and x equals 2, and then check your answer.